2:17 a.m., a monitoring station detects something unusual. It wasn't atmospheric noise. It wasn't common interference. It was structured. He logs the time, restarts the system. The signal comes back. The universe is loud, but it is rarely orderly. This signal was different. When the signal was converted into data, something unsettling appeared. There was repetition, but not randomness. It looked intentional, but intention requires a source. It vanished, as if it had never been there. It wasn't continuous. It was intermittent, almost responsive. What if the signal wasn't a message? What if it was simply confirmation? We don't know who sent it. We don't know where it originated. But we know it was real. And we know it could happen again. On August 15th, 1977, in the quiet of a summer night at Ohio State University's Big Ear Radio Observatory, a signal arrived from the depths of space. It was a moment that would etch itself into the annals of astronomy, a whisper from the cosmos that has puzzled scientists for decades. This is the story of the WOW signal. Our universe is a symphony of noise. From the moment of the Big Bang, a faint afterglow has permeated all of space. This is the cosmic microwave background, the oldest light in the universe, a constant, gentle hum that our radio telescopes can detect. It's like the static between stations on an old radio, a reminder of our cosmic origins. But amidst this background hiss, other natural sounds emerge. Pulsars, the rapidly spinning remnants of massive stars, emit beams of radiation like celestial lighthouses, creating rhythmic pulses. Quasars, distant galaxies with supermassive black holes at their centers, blaze with incredible energy, shouting across billions of light years. These are the natural voices of the universe, predictable and understood. To listen to these voices, we build incredible instruments, radio telescopes. Unlike optical telescopes that capture visible light, radio telescopes use massive dishes to collect faint radio waves from space. Think of it like a giant ear, focusing these weak cosmic signals onto a highly sensitive receiver. The receiver then converts these radio waves into electrical signals, which a computer records and analyzes. Astronomers can then visualize this data, often as a spectrogram, a graph that shows the signal's intensity over different frequencies in time. A natural signal, like the hiss from a distant galaxy, usually appears as a broad, steady band across many frequencies. It's like the sound of wind, a general rush of noise. But the signal that the Big Ear telescope detected that night was different. It wasn't broad, it was narrow and powerful, concentrated at a specific frequency around 1420 megahertz. This frequency is significant because it's naturally emitted by hydrogen, the most abundant element in the universe. Scientists had long theorized that any intelligent civilization trying to communicate would use this watering hole frequency, a universal channel for cosmic conversation. An artificial signal, one created by technology, would look just like this, a sharp, clean spike on a spectrogram, standing out dramatically from the wide, fuzzy static of natural background noise. It's the difference between a random burst of static and a clear, deliberate whistle. For 72 seconds, the Big Ear listened as the signal grew stronger, peaked, and then faded away, exactly as expected for a source moving through the telescope's fixed field of view. The computer printout showed a string of numbers and letters representing the signal's intensity. One sequence was so astonishing that astronomer Jerry Inman, who was reviewing the data days later, circled it in red ink and wrote a single word in the margin. Wow. The signal was 30 times stronger than the background noise, clear, unambiguous beacon from the direction of the constellation Sagittarius. The news sent ripples through the scientific community. Was this it? The long-awaited proof that we are not alone. The first step was verification. Astronomers around the world, from the Arecibo Observatory in Puerto Rico to the Parkes Observatory in Australia, turned their own powerful telescopes towards that same patch of sky. They scanned relentlessly, hoping to hear the signal again, to confirm its existence, but there was only silence. The signal had vanished as quickly as it appeared. It was a one-time event, a cosmic ghost that left behind a tantalizing clue. With no second observation, scientists turned back to the original 72 seconds of data. They dived deep, analyzing every nuance. The spectrogram was clean. It showed a single, pure tone, unwavering in its frequency. This wasn't the messy signature of a natural phenomenon, okay? They looked for mathematical patterns, for any hint of modulation that could carry information. Was there a repeating sequence, a hidden message encoded in its pulse? Despite decades of analysis with increasingly sophisticated tools, no discernible pattern emerged. It was a powerful, intelligent-looking signal that said nothing. This led to a flood of theories. What could have caused it? The first and most straightforward explanation was a rare, undiscovered cosmic phenomenon. Perhaps a unique type of pulsar or a specific chemical process in an interstellar cloud could mimic an artificial signal under just the right conditions. But no known natural source fits the signal's narrow band characteristics. Another possibility was closer to home. Human technology. Could it have been a signal from a satellite, an aircraft, or even a terrestrial source bouncing off space debris? Investigators checked flight logs and satellite orbits. Nothing matched the signal's location and timing. Furthermore, the signal was at a frequency internationally protected for astronomical research, making terrestrial interference less likely, though not impossible. One theory even suggested it might have been caused by the hydrogen clouds surrounding two comets that were in the area at the time. But subsequent studies have largely cast doubt on this, as the signal strength would have been far too weak. And that leaves the most extraordinary theory, that the WOW signal was exactly what it appeared to be, a transmission from an intelligent extraterrestrial civilization. It's a powerful beacon, perhaps, sweeping across the galaxy. The big ear might have just been in the right place at the right time to catch a fleeting glimpse as the beam swept past Earth. If so, it would be the single most profound discovery in human history. So why, after all these years, does the WOW signal still capture our imagination? Because it remains the strongest candidate for an extraterrestrial signal ever detected. It perfectly matches our expectations for what a deliberate, artificial signal from space would look like. Its elusiveness is what makes it so compelling. It's a mystery that endures, a single data point that challenges our understanding of the universe and our place within it. It's the 72 seconds of data from that summer night in 1977 serve as a constant reminder that there are still vast unknowns out there waiting to be discovered. It keeps us listening, searching, and wondering. Thank you for joining us on this journey into one of astronomy's greatest unsolved mysteries. If you found this as fascinating as we do, please like this video and subscribe to our channel for more explorations into the cosmos. Keep looking up.